all the fixed length schemes will have a fixed number of bits for every symbol. Okay. Now let us see what is the problem. Okay. Now there is for this character universe, now there is a string like this. G is not there. Okay, so on and so forth. And what is the length of this string? This is 100,000 characters length. So there are 100,000 characters like this, only consisting of these 6 symbols only. Okay, so these 100,000 characters are consisting of these symbols only, nothing outside this. Okay, so we have a string of length 100,000. Okay, now if I have a string which has repeatedly these characters for 100,000 times, let us consider this example. For this example, A is occurring 2 times here, 2 times here, and 2 times here. Frequency of A is equal to 6. Frequency of B is equal to 4. B is present 4 times. Now, similarly, imagine for this 100,000 character length string, okay, A will be occurring multiple times, B will be occurring multiple times. Okay, so similarly we can calculate frequency of A, frequency of B, frequency of C, so on and so forth. Okay, and since the length of the string is 100,000 characters, now these frequencies also will be in the order of thousands. A is occurring 45,000 times, B is occurring 13,000 times, C is occurring 12,000 times, D is occurring 16,000 times. Okay, and your E is occurring 9,000 times. Okay, and F, it is occurring 5,000 times. Okay, so since we know that the frequencies now, let us just calculate what will be the fixed length number of bits required and the variable length number of bits required. For the fixed length scheme, you see every code word is taking 3 bits. So if A is occurring, हेलो, हाँ सर मैं क्लास ले रहा हूँ, मैं कॉल कर रहा हूँ आपको. सर मेरा तो एक क्लास चल रहा है, मैं थोड़ा टाइम में आपको कॉल करता हूँ. Okay, so if every length is being used 3 times, okay, now A is occurring how many times? We are saying A is occurring 45,000 times. And for each occurrence, 3 bits will be used. So 45,000 times into 3 bits. Okay, B is occurring 13,000 times into 3 bits. C is occurring 12,000 times into 3 bits. D is occurring 16,000 times into 3 bits. E is occurring 9,000 times into 3 bits. F is occurring 5,000 times into 3 bits. Okay, so yes. Now for all these values, if I calculate the total number of bits, the total number of bits will come to be 300,000. A simple calculation. 10,000 characters are there. Each character is taking 3 bits. 10,000 characters will take 300,000 bits. Yes or no? Similarly, let us calculate the number of bits that are required for our second example.
That is 100,000, right? That is 1 lakh, no, right? So
yes. 100,000 is 1 lakh, right?
So you told 10,000.
No. By mistake I would have told 100,000. Okay,
Yes.
100,000 into 3. Okay, that is equal to 300,000. Yes. Now is it clear?
Yes.
Yes. For the variable length case, now let us take for the same example. A is occurring how many times? 45,000 times. But the length of the code word of A is now 1. So 45,000 into 1. Okay. 13,000 into 1. Into 3. 12,000 into 3. The length of C is 3. Similarly, this is for A, this is for B, this is for C. Now for D, let us calculate. Similarly, 3 bits are used. How many times D is occurring? 16,000 times. So 16,000 into 3. E is now occurring 9,000 into 3. Into 4. Now F is occurring 5,000 times into 4. Okay. So for this fixed length code, now the total number of bits that you require, if you calculate it, it will be something like 2,24,000. Okay. In comparison to the 3 lakh bits or 300,000 bits that you required, now you just require 224,000. Okay. So this marks the difference between a fixed length code and a variable length code. So by using a fixed length code, we will incur more space because more number of bits will be required. And for the variable length code in similar capacity, we will require lesser number of bits. So for this, from this example, it is clear that a fixed length encoding scheme is not more efficient than a variable length encoding. In other words, a variable length encoding scheme is more efficient. When it is more efficient? When the number of symbols are occurring irregularly. Okay, if they're occurring, if A is occurring 50 times, B is occurring 50 times, C is occurring 50 times, then a fixed length code is good. But if your number of occurrences are variable, then a variable length code is more preferable. Okay. Now we know for a fixed length code, we can assign a fixed length code with the number of symbols. Okay. For example, to A, I'm giving the binary value 0, binary value 1, binary value 2, binary value 3, binary value 4, binary value 5. Okay. 101 is 5. Okay. Don't ask me how. So yes, I will just assign the binary values in increasing sequence. G was there, then 6 will be assigned. F was there, binary value 6, binary value 7, all those things will be assigned. 1, 1, 1 and all those things. But how to find out a variable length code? Now I told you that this variable length code is better than the fixed length code. Okay, so if the variable length is better, then we need a mechanism to find the variable length code also. Okay, so our mechanism to find the variable length code is known as Huffman codes. What Huffman codes will give you? It will give you the variable length codes. Okay, so let us understand how Huffman code can find out a variable length code. Okay. We'll come to this slide. Okay. Yes. Now, if I just write down, this is nothing, this is the table. Okay. What the table is saying, A is occurring 45,000 times, D is occurring 16,000 times, B is occurring 13,000 times, C is occurring 12,000 times, E is occurring 9,000 times, and F, it is occurring 5,000 times. Okay, so now if I take these values, okay, now if I take these values, the first thing you notice here is they are arranged according to the increasing order of their frequencies. Okay, why? Because A is occurring most frequently, F is occurring less frequently. F is occurring 5,000 times, A is occurring 45,000 times. Okay, 9 times more. Now, after this is the first step of Huffman code. Arrange all the symbols in the increasing order of their frequency. Okay. Once you have arranged that, Huffman code is now saying combine these two, okay, to form a new node Z, okay, whose frequency will be the combination of these two frequencies. So Z's frequency will be 14. Why? The frequency of 5 plus 9. Okay. Now add this into the queue with the remaining symbols. Okay. So again, sort them. So what we have done basically, we have combined F5 and E9 to become a new node 14. Okay. And if you now insert this 14 here, then 14 will come after 12 and 13. So 12 will come, then 13 will come, then only the 14th node will be placed. And 14 node is again composed of two things, F5 and E9. Okay. Now, this after the first iteration, this is how the set of nodes will look like. Okay. Now, between these two, again, these two will be combined to become a new node 25, and that will be inserted. If that is inserted, 14 will come first, then 16 will come, then 25 should come, and finally we have 45. Okay. Again, here in the third step, you combine these two. Once I combine these two, now the new node will have, let me just create the new node. Okay. Now I am combining 14 and D16. So my frequency will be 14 plus 16, which is equal to 30. Okay. And this will have two sides, left side and the right side. Left side will have a node 14. Okay. And right side will have D16. The left side 14 will again have two branches, F5 and E9. Okay. So if you see, again we have to insert this into the remaining array. These two are remaining now. Okay. 25 and 45. So now it will become 25, which is shown here. Okay. First it will be 25. Then this combination of 14 and 16, which is 30. Then we have A45. Okay. Now they are arranged according to their increasing order of their frequencies. Okay. Now 25 will be combined with 30. If we combine this, this will become 55. If this becomes 55, left side will become 25, right side will become 30. Okay. Left side will become C12, right side will become B13. Okay. Again, this will be 14, the same one, just this will become the subtree. This will 14 will have F5 and E9. Okay. Now 45, if you arrange them, 45 will come first, then the 55 tree will come. Now these two will be combined. The total your frequency will be 100, and 100 will have a left child which is 45. It will have a right child which is 55. Okay. 55 as we have created, this entire subtree will now become the left child of 100. Okay. This will end our creation of the Huffman tree. Okay. But this creation of the Huffman tree will not give us the codes. Now, we need to traverse the tree to decode the code words. Okay. And how do we traverse? We will always start it from the root. Okay. So the root will always be 100. Okay. So if the root is 100, now we will, if we traverse left, then we encounter a 0. So, and where we reach A45. So A45 can be reached from this route with a symbol 0. Okay. Now from this route, again if we traverse to the right, we encounter a 1. Again, if we traverse left, we encounter a 0. Now from this 25, I have two options. Either I can go left, which will be 0, or I can go right, which will be 1. So if I go 0 or left, then it will reach me at C12. If I go right, it will reach me at B13. Okay. Now once we have completed this branch, now from here itself, we have another branch also. We have to also decode that branch. So if I go and I encounter a 1, from this 0 we had encountered 0, so we had found these two branches. Now from 1 we can also encounter a 1. Then we have two options again. Either I can go 0 or I can go 1. So it will be 1, 1, either 0 or 1. If I go 1, I will reach D16. Okay. And if I go 1, 1, 1, then I go for 1, 1, 0, then again I will have two options. Either it is 0 or it is 1. Okay. Either it can be a 0 or 1, 1, 0, 1. So this will give me F9. This will give me, F5 and E9. Okay. Let us go back to the example that we had taken. Yes, this example. Now from this example, if I just find out the values here, you see this value is A is equal to 0. We have already found out A45 is equal to 0. Okay. And we have found out that, let me just write it here. From this example, we found out A is equal to 0, B is equal to 101, C is equal to 100, D is equal to 111, E is equal to 1101, and F is equal to 1100. Okay. Let us see through the Huffman codes, we found the same values or not. So if you see, for C, I have found 100. For D, I have found 111. For D, I have found 111. For E, I have found 1100. 1101, sorry. For E, I have found 1101. For F, I have found 1100. And for for B, I have found 101. For B, I have found 101. A, I had already found it 0. So this is how the exact variable length code can be found out by using the Huffman's algorithm. Okay. So yes, this is the exact algorithm now. So what it is doing, it is placing everything into a mean priority queue. Okay. Where the priority is the frequency. So now they will be arranged according to their frequencies. Okay. Once they are done, now for the next two nodes, okay, we will call the